Welcome to Physics Tutorials. In today's class, we shall be looking at the topic linear expansivity. Now, after today's class, you'll be able to understand exactly what linear expansivity is, and then you'll be able to solve problems involving linear expansivity. So let's look at this together. Now, expansivity is from the word expansion. And what is expansion? Or more precisely, what is linear expansion? Expansion itself is increase in size. So when we say linear expansion, we mean increase in size of an object in a direction, probably the length of that object. That's increase in the length of the object, or the width, increase in the width of the object, or even the breadth, increase in the breadth of the object. So these are all referring to linear expansion. Now, substances expand when heat is supplied to them, but then different substances expand in different ways, depending on the material of that substance. So on the board here, we have two different substances, two different metals actually. The first one is zinc, and the second one is iron. Now, I'm starting with the same length of each of the materials. Let's take it to be 1 centimeter each. Now, if I supply heat to each of these materials, after some time, the length of each of the materials would have increased by a certain amount. It will have increased by a certain amount because of the addition of heat to each of these metals. But the length that zinc would increase by will be different from the length by which iron would increase by, because the material that was used in making zinc is different from the material of which iron is composed of. So they will not expand at the same rate, and they will not have the same increase in length. So because they won't have the same increase in length, they will definitely not have the same linear expansivity. So expansivity has to do with how each material expands when subjected to the same temperature rise. And that is exactly what we are going to be looking at this afternoon. So for zinc would expand more. So if, for example, I subject each of these materials to 1 degree Celsius rise or 1 Kelvin rise in temperature, zinc would expand more. I'm just using this to explain. I'm not saying that this is how much it will expand. So zinc would expand more than iron. So the expansion of zinc will be more than that of iron for the same temperature rise, because the material of which zinc is made of is not the same material of which iron is made of. So having understood that, let's now derive an expression for the linear expansivity of any given material. Now, to obtain linear expansivity of a material, we must first of all know what we call the original length. Original length. So we use L1 to represent original length of any material in calculations involving linear expansivity. Then we have to also know what we call new length. New length. We use that as L2. New length L2. Then we have what we call the original temperature. Original temperature. We represent that with this theta, we call it theta 1. Then we also have what we call new, or sometimes we call it final temperature. we use that as theta 2, new or final temperature. Now, we now have what we call the linear expansivity. Linear expansivity. We use the Greek letter alpha to represent that. So to obtain the linear expansivity of any given material, we must know, number one, the original length of that material prior to subjecting it to a certain temperature rise. Then we must know the final length or the new length of the material after it has been heated. Then we must know the original temperature. Before heating, what was the temperature of the material? Then after heating it, what was the new temperature? With this information, we can obtain what we call the linear expansivity of the material. So what then is the linear expansivity? There's a formula which I'm going to state here. It says alpha is equals to L2 minus L1 all over L1 into bracket theta 2 minus theta 1. In other words, the linear expansivity of any given material is the increase in length. You know, when you subtract original length from the new length, we have what we call the increase in length. That is L2 minus L1. You divide that by the product of the original length as well as the difference between the initial temperature and the final temperature. So let me come again. Linear expansivity of any given material is obtained when you find the difference between the original length and the new or increase in length, new length. So when you find the difference between the new length and original length, which is L2 minus L1, you now divide that by the original length and then the product of the original length multiplied by the difference between the initial temperature and the final temperature. When you multiply that one out, when you do all this calculation, you have what is called the linear expansivity. So linear expansivity. Linear expansivity is measured in per degree Celsius or per Kelvin. So the unit is per degree Celsius or per Kelvin. So what then is the linear expansivity of a substance? By definition, linear expansivity is simply defined as the increase in length per unit length per degree rise in temperature of any given substance. Increase in length per unit length per degree rise in temperature of any given substance. And I just told you now that the unit of linear expansivity is per degree Celsius or per Kelvin. So unit is equals to per degree Celsius or per Kelvin. Per Kelvin. So I hope with this explanation you have understood exactly what linear expansivity is. In the next class, we shall be looking at solving problems involving linear